Hello everybody. In this problem we're going to do an application of a quadratic function, which is specifically the free-fall equation. In the free-fall equation, we're told that the height of an object h is equal to -1/2 its gravitational constant times t squared plus the initial velocity v0 times t plus the initial height h0. In our problem, a wrench is dropped from a height of 50 feet. We're asked to find the time at which the wrench will hit the ground. How fast will it be going at that point? In order to do this, let's go ahead and get our actual equation for the height of the object at any time t. Height will be equal to -1/2. In feet per second squared, we're going to use the number 32. 32 feet per second squared is our gravitational constant times t squared. Our initial velocity is 0, right? If we're dropping from a height, we're not launching it, we're not having attached rockets to it or anything else like that. We're just going to make it 0, right? So we're going to have a 0 times time. And of course, our initial height is at 50 feet. So we're going to add that to the end. We should simplify this just to make it easier to work with, and that's going to mean that we're going to have -16 t squared plus 50 represent the height of our object at any time t of the object above the ground. Well, what time will the wrench hit the ground? Well, the time at which the wrench will hit the ground is going to depend on how fast when it gets there, and of course, on the ground, our height is equal to 0 feet. So what we're going to do is we're going to substitute that in and we're going to solve. So we're going to say 0 is equal to -16 times t squared plus 50. Solving, the method is to let's move our 16t squared to the other side by addition, and adding 16t squared to both sides gives me 50. And then I would divide both sides by 16 to isolate t squared. So to solve for t, we have to take our square root on both sides. When we reduce, we're going to say t will be normally equal to positive or negative the square root of 50 over 16. But since t represents time, t must be greater than or equal to 0, so we're only going to deal with the positive root only. And our case is going to give us t approximately equal to 1.77 seconds. If we wanted to move on to ask how fast it will hit the ground, we're going to use an instantaneous velocity equation. We actually developed this equation in calculus, but for our application, let's just worry about what will the velocity be when it hits the ground. And this is going to be a direct substitution again. We're going to use v equal to negative of 32 feet per second times time plus that initial velocity of 0. Well, it's 0, so we don't have to worry about that. Let's make our substitution. To find the velocity, we would take -32 and multiply that by 1.77. Doing so gives us a velocity of about -56.57 feet per second. How fast is -56 feet per second? Well, if we were really interested, we could see what that would be in terms of miles per hour by doing a brief conversion. Remember that there are going to be 5,280 feet per mile. And there's going to be a rate, or there's going to be, if we're going to go miles or per hour, we need to convert seconds to hours. And there are let's see, 60 seconds per minute and 60 minutes per hour. That's 3,600 seconds per hour. All right, so if we're going to do a conversion, let's go ahead and just do this conversion off to the side. I'm going to get a little bit of a thinner line so I can fit more of this in right here. I'm going to try and write this in neatly. Let's convert. If you're interested, 56.57 feet per second. We're going to change that into miles by taking 1 mile for every 5,280 feet. So feet will divide out. And 3,600 seconds divided by 1 hour. Doing the unit analysis, the seconds divide out, feet divide out, and we're left with miles per hour. And when I work this out in my calculator, I get approximately 38.6 miles per hour. Ooh, that's a pretty fast hit for 50 feet.